what a function is. A function is a relationship in which each element of the domain is paired with exactly one element of the range. Okay? Each element of the domain, the input, is paired with exactly one element of the range. Got it? So, down here is a table of what a function looks like. Notice here we have an example. This is a mapping. Remember that from the other day. And so each element of the domain, so the -3 is paired with 5, exactly 1. 0 is paired with exactly 1. 2 is paired with exactly 1. And 4 is paired with exactly 1. Okay? A function will look like this. Okay? Notice the function. It's just a continuous line. The function will eventually talk about passes something known as the vertical line test as well. Okay, but each element of the domain is paired with exactly one element of the range. So we're now to look at these and determine, is this in fact a function? So let's look at that first one. And this is just a little test that you go through. Is -2 paired with exactly one element of the range? Yep. Is 0? Yes. Is 3? Yes. Is 4? Yes. It doesn't matter that both 0 and 3 go to 6. Okay, it doesn't matter, as long as they're only paired with 1. So this is in fact a function. Let's look at this one. Is 1 paired with exactly one element of the range? Is 3 paired with exactly one element of the range? Is 5? Is 1? Let's look at that again. Aren't those the same numbers? I mean, that's the same number, right? So the number 1, is it paired with exactly one member of the range? No, because it's paired with both 4 and -4. So this one is not a function. So things you're looking for duplicate numbers on the domain side. All right, let's go through this. We have the number 2. Is that paired with exactly 1? No, why is it not paired with exactly 1? There's another 2 right here. Okay, and see, it goes to both 1 and -2, so this is not a function. It is also not a function because notice here we've got the number 3. 3 goes to both -2 and +1, so that actually fails twice. But that's what you're looking for. You're looking for duplicates in the domain. So now we're going to define what a discrete function and what a continuous function is. Now this is in your book. It's not really that difficult. Basically, a discrete function, the graph consists of points that are not connected. So the graph basically just is a bunch of points. So discrete function is going to look something like this. Okay? A continuous function, on the other hand, is going to look something like this. Let me mark those in blue so that they stand out a little better. Okay, so that's the difference between a discrete and a continuous. A discrete just has a bunch of dots, a bunch of points. A continuous function, on the other hand, has a line. So a good thing to do if you're writing notes down, you don't necessarily need to have the words. You could just have the pictures, discrete function and have a picture, continuous function and have a picture, and then that basically explains what the two are. So let's go ahead and look at the next slide and see what we have. Okay. It says at an ice sculpting competition, each sculpture's height was measured to make sure that it was within the regulated height range of 0 to 6 feet. The measurements were as follows. Team 1 had 4 feet. Team 2 had 4.5 feet. Team 3 had 3.2 feet. Team 4 had 5.1 feet. And Team 5 had 4.8 feet. It says make a table of values showing the relation between the ice sculpting team and the height of their sculpture. So we need to make a table of values. So we could do this team, and we could do height. Now I could do either a vertical table or a horizontal table. It doesn't matter. Okay, and I'm just going to list the teams. We have how many teams? 5. What was team 1's height? Team 2. Team 3. Team, short one, 4. 5.1, and Team 5, 4.8. So there's our table. Okay, that's step 1. Pretty straightforward. It says determine the domain and range of this function. So our domain and our range, what's our domain going to be first? Nice job. 1, 2, 3, 4, 5. So it's just this first column. Okay, what about the range? Nice job. Okay, so there's your range. Okay, so that's just your second column again. So now it says write the data as a set of ordered pairs. So my first ordered pair is going to be what? 1, 4. Good. What's my next ordered pair? Nice job. What's my next one? Okay. 4, 5.1. And then 5, 4.8. Now, if I were going to graph all of those, is that going to look like a discrete graph, a bunch of points, or is it going to look like a continuous graph with a line? So if I plot all these points, what's it going to look like? Discrete or continuous? Discrete, because what is it? It's just dots. There's not a line or anything, it's just a bunch of dots. All right, so let's talk about the next thing, the vertical line test. If you remember, we briefly talked about this at the start. Basically, a function, okay, has to pass the vertical line test. And what the vertical line test means is that if I take a vertical line, so if I take a vertical line, like right here, and I move that vertical line throughout the graph, it can only touch the graph once at any given time. So does the orange line only touch the graph once at any given time? Does it touch it once here? Yep. Once here? Once here? So if it touches once at any given point, it is a function. So this one would be a function. Let's look at this next one. Is this next one a function? If I take that line, imagine my pencil, moving it across the graph, does it only touch it once? No, how many times does it touch it now? Twice. So this is not a function. Let's look at this next one. Is this a function right here? Let's check right here. Does it only touch at one point there? It touches at one point on the closed. What about this open? Does it actually touch that graph there? No, because it's open. Okay, so that one actually is a function based on that. Okay, so it is in fact a function because of that open circle. Now, if that circle up on the top would have been filled in, let's say for example it was like that. Then if I would have moved my, line over, oh, better now it's not lined up, there. Then if I would have moved this line over, it would have touched at 2 points, and that would not have worked. Okay, so the open circle, remember, means that there is not a point there. So that's the vertical line test. So now it says determine whether the following graphs are functions. So what we're going to have to do is we're going to have to graph this. Now, do you remember how you graphed in middle school? What did you do when you wanted to graph a line? Didn't you make a table? Okay. So the very first thing what I'm going to do is I'm going to solve this equation for y because it's going to be a little bit easier. So I'm going to add 3x to both sides. So really then I get y to equal 8 plus 3x. So first value I would let y equal, or x equal, sorry I said that wrong. I'm going to use the values 0, -1, and +1. Okay, that's what I always use. That's what I've always been accustomed to using. So now what I'm going to do is plug in -1 for x. So if I plug in -1 for x, what's -1 times 3? What's -1 times 3? -3. Add 8, you get 5, as you've already said. So now what I'm going to do is I'm going to graph that. So I'm going to go ahead and put in my x and my y's. So here's your x, here's your y. I'm going to plot the point -1, 5. There's my dot. Now I'm going to do the same thing with 0. I'm going to plug 0 in. So if I plug 0 in here, what do I get? 8. So I'm going to plot the point 0, 8. Oops, I'm going to run out of room. And then now I'm going to plug the point 1 in. If I plug the point 1 in, what do I get? 11. So I've already run out of room, and so we'll put it up here. And so all I have to do now is draw the line in. Now if I look at that graph, would it pass the vertical line test, yes or no? So if I move a vertical line, if I move my pencil across this graph, does it only touch at one point? So is this a function? Yes. Okay. Let's look at this one, 4x equals 8. That one doesn't have a y. Okay. Ideas? Since it doesn't have a y, what should I do? If I just gave you the problem 4x equals 8, what would you do? Close. What would you do? Close. Divide by. Yep, divide by 4. And so when I do that, I get x to equal what? Close. 2. There we go. Okay, so let's think about, on my graph right here, where would x equals 2 be located at? To where? To the right. Be right here, right? Okay, and so if x equals 2, does x equal 2 also, does x also equal 2 here? Does it also equal 2 up here? Yeah, because that'd be like the point 21, 22. So really, x equals 2 is a vertical line. Would that pass the function test, the vertical line test? If I put a vertical line right here, is it only going to touch at one point? It is? How many points is it going to touch at? A ton, right? It's going to touch along the whole line. So this is not a vertical line. Or not a function, sorry. So real quick, something you might want to file away. X equals 2 is going to be a vertical line. If you had something like y equals 3, this is going to be a horizontal line. Okay, so that's just kind of one of those things to file away. X equals is going to be your vertical line. Y equals is going to be a horizontal line. Now we've got a few problems to end with today. Okay. I know some of you are writing that down, so. And it could be y equals anything. It could be y equals 4, y equals 5, y equals -1. Okay, but if it's just y equals some number, that's a horizontal line. So function notation, if you've ever wondered why it says f of x, all that means is that's just function notation. F stands for function of x. Okay, so for f of x equals 2x minus 3, find each value. So all I'm going to do is exactly what I did about 2 slides ago when I plugged it into the xy chart. I'm just going to plug 1 in here. So I've got 2 times 1 minus 3. What is that going to give me? -1, good. What about -2? Plug in -2. I take 2 times -2 and I subtract 3. So what is 2 times -2? Minus 3 is negative what? Negative what? 7. Okay, because it's like -4 and -3. Okay, let's plug in this one. Notice what it says, 6 minus f of 5. Okay. So the first thing I'm going to do is find what f of 5 is. So if I plug 5 in here, what do you get? 7. So really my problem is 6 minus 7. What is 6 minus 7? Negative 1. So that is my answer. See how that works if you have other things in there? This one is f of negative 1 plus f of 2. So if you plug negative 1 up there, now be careful on this one. What do you get when you plug negative 1 up there? Negative 5. Good. Plug 2 in. What do you get? 1. So what would your answer be? Negative 5 plus 1? Negative 4. Nice job. So those you're going to have to plug in for functions. Okay, do you think you, let's go ahead and look at the first few ones up here. It says find f of 4. So on this one, we have to do order of operations. So what do you have to do first for order of operations there? You have to do the exponent, right? So I have to do the 4 cubed first. So I have to do the 4 times the 4, and what do I get? And then I got to take that times 4, and I get 64. So really, I've got 2 times 64. So if I take 2 times 64, I get 128. Okay. The negative 5 will be the same thing. All right. Now this one, this 3 times f of t plus 2. Okay, what do you do with the t? You're going to plug it in right here for the x. And so really, if I plug it in there for the x, this is all I'm getting. Okay, and that's, you can't simplify that any. And what's the only thing you can do then before you circle your answer? There's one operation, one thing you can do now. What can you do? Times the 3 and the 2, and what do you get? So really, your answer is going to have a variable in there, and that's okay. Alrighty, the f of negative 3 minus f of 1 is just like the one we looked at previously. You're going to subtract the 2. So what I need you to do for me, for tomorrow, I need you to do 52 through 53, 20 through 48. Now, we've got a real quick quiz that I also need you to do. Okay? So, let's stop.